Hello, Senior One. I hope that you're fine. Today, you're gonna talk about a very important lesson in physics, which is vector and scalar. You have an idea about this lesson from the Level 3, as you know, but today we're gonna revise some of the main concepts that you had already in the Level 3 and complete to the higher level, which is related to the physics in Senior One. Okay, so as you know, what is the difference between the vector and the scalar quantity? The scalar quantity, it's a physical quantity that can be measured or that can be determined by giving a value or magnitude for it and just a unit. So if I ask you about the temperature of a person, you're gonna say it's 37, almost 37 Celsius. It means that you give me a magnitude for the this quantity and give me a unit. So what's the difference between the scalar and the vector? Both of them are physical quantity. One of them is measured by giving its magnitude and unit only. And the other, or the vector, it's determined by giving a magnitude for it and a direction, unit of course, and direction too. So the difference between the vector and the scalar quantity, we can consider the direction which determines the vector. So if the direction can change the value of the vector quantity, yes, of course, it can change the value of the vector quantity. So some of the physical quantity that you have to know about its vector, and it's determined by the direction as displacement, velocity, acceleration, force, and weight. How about some of the scalar quantity that you've studied before, like the mass, like the distance, like the time, like the temperature, okay, like the speed, because we don't have to mention the direction of the speed of some person. So as I mentioned here, we have two different physical quantity. One of them is called the scalar, and it's determined by giving the magnitude and the unit, and the other is the vector, and it's determined by giving the magnitude, unit, and direction. Examples for the vector is displacement, velocity, acceleration, force, weight, and we have other unit called momentum. Okay, so when it comes to calculate the value of the vector quantity, you have to bear in mind the direction. Suppose that we have a person move from point A to point B, covering 5 meters in this direction, and then moving from point B to point C, covering other 5 meters in this direction, and return back from point C to point A, covering the same 5 meters. And I ask you to find the distance and displacement of this person. The distance will be all the numbers or all the meters that covers by this person. So it's gonna be 5 plus 5 plus 5, it's gonna be 15 meters. We just mentioned here the value or the magnitude of this unit and the unit only. How about the displacement? The person moves in this direction or to the east direction, covering 10 meters to the east, and then return back in the other direction 5 meters to the west. If we subtract both from them because they have different direction, you're gonna find that the displacement will be 5 meters in the direction of the longest displacement he covers will be to the east. So the changing of the direction change the value and the magnitude of the displacement. So we can consider the value or the magnitude of the displacement is the shortest straight line from the start to the end point. This represents the displacement. So the direction changes the value and the magnitude of this physical quantity. Suppose that person moves in a circle, and I ask you that if he moves in a complete cycle, what is with the radius equals 5 meters, and ask you to find the distance covered by this person and the displacement. The distance will be, he covers the whole perimeter or the whole circumference of the circle, and the circumference of the circle gonna be 2 by r. So it's gonna be 2 times pi times the radius will be 5. But if I ask you about the displacement, where is the start point? He starts from A and then move along the circumference of the circuit, but the displacement, as I told you, it is the shortest straight line that joins between the start and the end. The start, he starts at A and ends at A, so there is no displacement between them. The displacement will be 0 because he returns back to the same starting point. But suppose he move in a half circle like this with a radius equal 5 meters too. He moves from point A to the point C to the point D and ask you to find the distance and the displacement too. To find the distance, it's the half of the circle or half of the perimeter, half of the circumference of the circle. So it's half times 2 by r. We can substitute the radius by its value, which is 5 meters. How about the displacement? He starts from A and he ends in D. So the shortest straight line that joins between the start point and to the end point will be the diameter. So the displacement will be 5 plus 5. It's gonna be 10 meters from the direction starting from A ending in D. Suppose a person moving in a 3/4 of a cycle like this, covering a 3/4 of a cycle with a radius 5 meters too. Start from A, moving through the circumference of the circle like this until he reaches to B, and ask you to find the distance and the displacement. As I told you that if you want to find the distance, you have to measure the actual length or the actual path that the person covers, but the displacement you calculate it from the start point to the end point in a straight line. So the distance will be 3/4 2 by r, and you substitute the radius by its value. How about the displacement? The displacement from the start point to the end point, it's gonna be this line, and we can calculate it from the Pythagoras. So the displacement will be r power 2 plus r power 2. So it's gonna be 2r power 2. So it will be r root 2. So the displacement in the quarter cycle or in a 3/4 cycle of a person with a radius r will be r root 2, will be r root 2. So how could we deal with the vector quantity? Actually, we will make 3 things in the vector quantity. We're gonna find the summation or how to add them together. We're gonna find the product of this vector quantity, and we're gonna find the resolution of this vector quantity. So we're gonna deal of the vector quantity in terms of 3 points. We find the resultant, and we have the resolution, and we're gonna find the product. First, what's meant by the resultant of the vector quantity? I'll give you examples here. Suppose that you have 2 vector quantity, they are moving in the same direction. So if I have 5 plus 5, they are in the same direction. So we're gonna add them together. And this, if I name this is A and this is B, they are equal. Vector A equal vector B because they have the same magnitude and they have the same direction. Suppose that I write 5A and this is B, vector B. we cannot write that they are equal here. Why? Because they have different directions. So if the value of the vector or the direction or one of them is a change, so the vector will not be equal to each other. But we can write that the vector A equal the negative of vector B because we changed the direction. If we write negative B, it means that we flip it or reversed, so we change the direction of it. How we add the vector together? As I told you, if they are in the same direction, we're gonna add them together. But we have two other ways to add or to find the resultant of the vector. Number one, by drawing triangle. So if I have a vector A moving in this direction and it's joined to the vector B moving in this direction, so the resultant will be from the start of the first to the end of the second. So the direction C will be vector A plus vector B. We draw here a triangle. We complete the vector by drawing the triangle from the start of the first to the end of the second, from the start of the first to the end of the second. And this is the total resultant of this two vector A and B, gonna be the C vector. We have other way by drawing a parallelogram. Drawing parallelogram. Suppose that you have two vectors like this, A and B. And they have the same vertex. How could we add them together or find the resultant of them? We're gonna find the resultant of them by complete this shape as a parallelogram here and find the point C or the direction C, the total resultant, which is equal A plus B. So this is the way to find the total resultant by drawing the parallelogram of it if they have the same starting point. If one of them, the ending point of the first is the start of the second, you're gonna draw the triangle. If the both of the vectors have the same starting point, so we're gonna draw it as a parallelogram, and the total resultant of them gonna be the line that in this direction represents the direction from the starting point of the vectors to the this point. We can name it E. Okay. So suppose that we have two vectors perpendicular in each other. I have vector Fy and I have vector Fx, and we're gonna find the total resultant of them. The resultant of these two vectors, if we move this to this direction, it's gonna be Fy. So the resultant will be from the start of the first to the end of the second in this direction. So this is the resultant. We're gonna calculate it from the Pythagoras theoretically. If we call this F, so F will be the square root of x power 2 plus Fy power 2. This is the resultant of the vector that we're gonna calculate it theoretically. By graphically, we draw this line, which is a line has a measure of theta here between y and x. So if we have two vectors and they are perpendicular in each other, we're gonna use the relation that F, or the total resultant vector on them, gonna be the square root of the Fx power 2 plus Fy power 2 under the root. Okay. If the theta is here, you know that the slope, which is equal Fy over Fx, may be equal the tan theta It's the opposite over the adjacent. So the tan theta of this will be the Fy over Fx. Fy over Fx. This is how to find the resultant of the two perpendicular vectors. How about the resolution? Suppose that you have a vector like this, and we're gonna call them, we're gonna call it F vector. And I want to make a resolution for this vector. What's meant by resolution? Resolution of the vector, it means divided to two direction, x and y. We're gonna divide it into fx, and we're gonna divide it or resolute to fy. And you'll find that the fx will be f if this make an angle theta with the fx, so it's f cosine theta, and fy gonna be f sine theta. So as I write here that the fx, it's the f cosine theta, while fy is the f sine theta. So we make the resolution for the f vector on x and on y. On x, it's so the fx will be f cosine theta, and the fy will be f sine theta. I'll give you example for this. Suppose that you have a vector f like this. We have two vectors. Fy that is perpendicular on the fx, making an angle 30 with the fx, and this it represents as f. The force of f is the resultant of the two fx and fy. If you want to find the f, so f will be fx cosine theta, or the force of F will be Fy sine 30. So this is how to find the resultant of the, if he gives you a number for the fx or the value of the fx and give you a number of fy, you're gonna substitute its value and find the total number here. So the last operation we're gonna do on the vector will be how to find the product of the vector. We have two types of the product. We have the cross product . We have the cross product and we have the cross or vector product. And we have the dot or scalar product. What is the difference between both? Here we have the value or the magnitude of the multiplying the two vectors together. So if we have a vector A multiplied by the vector B, we're gonna find that AB or A times B, the product of both of them, gonna be AB cosine angle between them, the cosine theta between them. While, and gonna give you an answer with the value only. So no direction in this, it's a scalar quantity, no direction for it. While in the cross product or the vector product A cross B, gonna find the direction of multiplying the both vectors. It's gonna be A, B, sine theta, n. What is n? N is the direction or the direction of the product of these two vectors A and B. And we're gonna use the right-hand rule to define the direction of the vector A cross B. What is the right-hand rule? As you see here, if we have two vectors B and A, and we have to find the cross product of them. The cross product of them gonna be in the C direction. As you see here, we do this by the right-hand rule to define the direction of the product, the cross product of the vector A and B. So if we write A cross B, it's gonna be in this direction. And if you want to find B cross A, it's gonna be in the down direction, not in the up. Here, how could the angles or the theta change the value of the dot and the scalar vector quantity? You know that the dot product, if you multiply to get the maximum and vanish value or minimum value for the dot product, cosine 0, if the theta is 0, you're gonna get that cosine 0 equal 1. So this is the maximum value for the scalar product. And if the theta is 90, so cosine 90 equals 0, so the cross product will be the minimum or will be vanish. How about the vector? It's the opposite. To get the maximum value, it's gonna be the maximum value for the cross product of the two vectors if the theta between them gonna be 90. And the two products of these two vectors gonna be vanish if the theta is 0, gonna be vanish, or it's gonna be the minimum value for it, as you see here. We have some notes. A dot B, it's the same with B dot A because both of them we consider the value of A and B only, not considering the direction. But if you want to make the multiplication or the product of them according to as a vector product, you have to make to bear in your mind or take in consideration the cross product. And in this case, A cross B will not equal B cross A, because we have different directions here. So when A cross B equals 0, it means that the angle will be 0, or they are equal. There is no angle between the vector A and B, because sine 0, as you know, is 0, so it vanishes. A dot B will be A cross A numerically if the theta between them gonna be 45, and it's very important numerically, not in the direction, because as I mentioned that A dot B has a magnitude only, and A cross B has a magnitude and direction, but here we consider the numerical value of it only. So they will be equal to each other if the angle between them, so 45, because the sine of 45 will equal the cosine of 45. A cross B will change the sign of B, so it will be negative B cross A. A dot B will equal 0 if the angle is 90, because the cosine 90 is 0, so it's vanished. It means they are the angle between them is 90, it means that they are perpendicular in each other. So we do the mathematical operation, or we do the operations on the vector. We make the resultant for the vector, we make a resolution, we find the product as a dot product or a cross product. And next time, inshallah, we're gonna solve a problem about it. Thank you for today.